Hi friends, welcome to Life with YouTube channel. So till now we have discussed many topics and today we are going to discuss about rank of a matrix. Many were confused between how we need to find a rank of a matrix, whether rank of a matrix may be a 0 or 1 or 2 or 3 of a square matrix. You'll think right. So we should have no confidence, we should have confidence and we should have no any confusion first of all. So further today we are going to discuss about rank of a matrix. So let's go. Rank of a matrix. So first of all, what is mean by rank? This we have particular definitions, but I'll save them in the middle because of when the time comes I'll say you. Okay, till that, first of all, rank. How many methods are there to find the rank? First of all, the thing is, how many methods are there to find the rank? We have 3 methods. Okay, M1 is equal to determinant method. Determinant method. Okay, you know how to find determinant, right? So the method 1 is determinant, and which will be easy to us. So and the determinant will find in 2 cases, that is in the square matrix as well as rectangular matrix. Okay, next method 2. Method 2 is number of non-zero independent rows. Okay, number of non-zero independent rows. Number of non-zero independent rows. What is meant by number of non-zero? You know, 0 is this, non-zero is it's not equal to 0. Okay, so non-zero row independent rows, the rows which are not dependent on the 0, are called number of non-zero rows. We need to count them and just we need to write them. Okay, so now rows or columns, whatever it may be. So completed next method 2. Now method 3. Now row echelon form. Row echelon method. What is meant by row echelon method? You may have the doubt, right? So the row echelon form is, if we have some matrix, or it may be a square matrix or a rectangular matrix, then if we need to make this is the diagonal matrix. If you think, for suppose if I write 1, 2, 3 and 4, 5, 6 and 7, 8, 9, this will be the diagonal matrix, right? Here the upper triangular matrix, this is the lower triangle, right? The lower triangular the lower triangular elements should be 0. Okay, if these are 0, therefore it is called row echelon form. So these are the 3 methods. Now let's go to one by one. Okay, I think you are understanding everything. So now let's discuss determinant method. So in this determinant method we have many cases. Okay, so therefore now we'll revise with case 1. What is case 1? If that, one of the thing I have forgotten to say you is the rank. What is mean by rank? We have to denote the rank with a symbol, and that symbol is R, or else you can simply write row. We'll call this as row. Okay, so R or row. Okay, is it fine? So now in case 1, if the det is not equal to 0, then the rank of a matrix is equal to, and if here one thing I am saying is, now we are discussing square matrix. First of all, in determinant itself we are discussing square. In that square we are discussing first of all case 1, if the det is not equal to 0, the the rank of a matrix will be n. If the order is n into n, as I said, it's a square matrix, right? So it will be n into n. Okay, so therefore the next case, I think so you have understood, that is not equal to 0. You know that I have said you two types of bets. I mean, on the basis of the determinant we have two matrices, right? I said, what is a singular and the next is non-singular, right? So the singular matrix, which I said, if the det is equal to 0, if the det is not equal to 0, it is obviously non-singular, right? So you can remember in that way also it's a non-singular matrix. Okay, so now we can discuss with case 2. First I'll say case. Okay, for a better explanation, just I'll say you example for each now itself. For suppose A is equal to 1, 2, 3, 4. This is a 2 into 2 matrix, right? Find the det of A. The det of A is 4 ones 4 minus 3 to 6, right? 4 minus 6 is minus 2. Here what I said, the det is not equal to 0. Here it is not equal to 0. Therefore, rank of a matrix is n. In which the order is n into n. So here n is 2. Therefore, the rank is equal to 2. Okay, is this fine now? So next, if det is equal to 0 of n into n matrix, let's take an example of here 3 into 3 matrix. Then listen here carefully. Row may be, the rank may be A, 2, or rank may be 1. Okay, rank may be 2 or rank may be 1. Here there are two cases in case 2 itself. What are those two cases to learn? We can learn that. So here row 2 is nothing but, here first of all we can discuss with row 1. It's very easy. If we find, for example, I said you have 3 into 3 matrix, right? So 1, 2, 3, 7, 11, 12 and 3, 0, 1. So this is the 3 into 3 matrix, right? If you find the det, what would be the answer? Just find that. So 1, 11 minus 2, just 7 minus 36 plus 3 into minus 33. So this is the det, right? Just calculate that, you'll get the answer. 7 minus 36 is nothing but minus 29. Minus 29 into 2 is nothing but 58, right? So minus and minus plus, so 58. Here we got minus 99, right? 58 plus 11 will get 69 minus 99 will get minus of 30. Okay, we'll get minus 30. This is a rough work, please neglect this. So here we have got det of, if you think it's a B, det of B is equal to, we got minus 30. Okay, so when the rank is equal to 1 means, if you think that we got the det is equal to minus 30, or else if you get the det is equal to 0, as I said you. So therefore, let's find the det for, if you think if I got a det for this, then the way we need to do is, here for example I'll say 1, 2, 3, 1, 1, 1, 0, 0, 0. Okay, so find it, you'll get 0. Okay, so here if the det is equal to 0, we need to find the det of the submatrices. Okay, so here this is the submatrix of 2 into 2 matrix. So here we have the submatrix as 1, 2, 1, 1, and we have here, if you take in this way, 2, 3, 1, 1, right? And we have more matrices right here. So 4 submatrices we have. So we need to find the det of those 4 submatrices. Then we'll get here 1 minus 2 is nothing but minus 1. In next case 2 minus 3 is nothing but minus 1. And here 0, 0, right? Here one thing I'll say that if the det of submatrices, if the det of at least one submatrix has that is equal to 0 is not. So here, if the det of at least one submatrix has that is not equal to 0, it's one thing I'm saying here, it's that is not equal to 0, then the rank of the matrix is 2. So if all the submatrices having a det is 0, therefore the rank is 1. Okay, do you have understood? I think so. For suppose in the case of 1 2 3 0 0 0 0 0 0, okay, this is the matrix. So here, if you find the det, you'll get 0, and if you find the det of submatrices of a 2 into 2 matrix, then you will get 0. So in this case, the row is equal to 1. So here you can write the, if the det of submatrices are all equal to 0, then the rank is equal to 1. If at least one submatrix is not equal to 0, therefore the rank is 2. Okay, if all the submatrices having 0 det, so therefore rank is equal to 1. So I think so you have understood this case 2. Now let's go to case 3. So here one thing you need to understand that the case 1 and case 2 is nothing but just I have discussed about the det, right? So, and one thing you remember here, now we are discussing determinant of a square matrix, not rectangular matrix. Okay. So now the case 3 is nothing but about null matrix. Okay, null matrix. Here now, until now they have said about a rank of a matrix, right? Here in this side we have got the ranks as a 1, 2 and 3 and not more. So here now the case 3 is, if A is a null matrix, det A, right? Det A will be 0. Null matrix, the det of a null matrix is 0, you know. So in this case the rank will be 0. Okay, in the case of null matrix we'll get rank as 0. Just remember, this is not a case to say that, it's a think as a like formula or to remember, or it is a note. Okay, so if A is a null matrix, therefore we can say directly we know, and determinant is equal to 0, therefore rank is also 0. Here don't think of in the case 2, in the case it's not, in case 2, if the det is equal to 0, then you think rank is 0. It's not correct. Okay, the det is equal to 0 only in the case of null matrix. In the case of null matrix, the rank will be 0. No need of any det. Okay, is it clear? So now we can go to case 4. Case 4. Think what will be the case 4. Okay, case 4. In 2 into 2 matrix, before what we have discussed in 3 into 3 matrix, right? Suppose 1 0 0 1. Here we are getting the det as 1, right? So here det is 1. Therefore here it is a 2 into 2 matrix. What I said, if the det is not equal to 1, therefore the rank of a matrix will be equal to n. So here 2. Okay. Now 1 1 0 0. Here, what is the det? Here the det is 0. Okay, but what is the rank? We need rank, right? Here the rank will be 1. 1. Why? You may have doubt, right? Here, just you need to do, here, this is the one. Take submatrix into matrix, then you'll get 1 into 1. Sorry. 1 into 1 matrix you'll get, right? So in that case, here 1, we'll get the submatrix as 1, here 1 into 1. So therefore the 1 will be the rank of this whole matrix, not the single matrix of the submatrix. Okay? So this is the case for in all square matrix finding determinant is the method 1. Now we can go to rectangular matrix. Okay? So in rectangular matrix, I can't say what is the order of the rectangular matrix, right? Because it may be of any order, but just I'll say you the way in which how you need to find the rank. Okay. One thing, the main important thing is, for example, we have a matrix of it is a 2 into 3 matrix, right? So here the rank will be, if it is a rank of A will be less than or equal to 2. It means that if here in the case of it is that m into n, therefore less than or equal to m, the rank will be this one. This is important thing, let's keep in your mind. But you know, if I said less than or equal to 2, right? Less than or equal to 2. So it may be 2. 0 it won't be. 0 only in the case of null matrix. Okay? Is it fine? So there is a case of 1 and 2. How we need to do? So for this, we have, we'll get some confusion in the rectangular matrix. For that, we have more 2 methods, and those 2 methods, as I said you, number of non-zero rows, right? For suppose if you have 1, 2, 3, 5, 9, 11 and 0, 0, 0. Here method 2 I am saying here. Method 2. Here 1, 2, 3, 5, 9, 11, 0, 0, 0. Here in this case, if you think this total one row is totally zeros. What I said, non-zero independent. Here these two are non-zero independent. Therefore, the rank will be 2. Okay? Rank will be 2. Okay? This is the non-zero independent rows. And the third one I said that row echelon form. Wait. Before that row echelon form, I will say you one of the important note. Here, if you have a matrix of 1, 2, 3, and here 2, 4, 6. This is a 2 into 3 matrix, right? Okay. Here, if you observe, if you think this is the row 1, here row 2, here row 1 is equal to, row 2 is equal to 2r1, right? Just think, row 2 is equal to 2r1. Okay? In this case, just in this case I am saying you now, here we get that R2 is equal to 2R1. In this case, if anything, Ri is equal to Krj. Here I and j are just think as rows, number of the rows. So here Ri is equal to Krj. In this case, the row will be equal to 1. Okay? In which case, if the Ri is equal to Krj, in that case we have the row, the rank will be equal to 1. Okay? So now let's discuss row echelon form. So in row echelon form, as I said, we need to make the lower triangular elements as zeros, and then we need to find that. Okay. So and that method is if A is equal to minus 1 4 6 3 3 2 1 0 1 minus 4 3 0, think as like this. So this is the row echelon think this is matrix. Now we need to make that into row echelon and we need to find the rank of a matrix. So for this, just we need to find we need to make these elements as zeros. Okay, for this I'm making A will be here, yeah, if you think minus 1 1 4, so row 3 implies row 3 plus row 1, therefore we'll get minus 1 4 6 3 3 2 1 0. Here minus 1 plus 1 0, 4 minus 4 is 0, 6 minus not minus 4, minus 1 plus 1 is 0, 4 minus 4 is equal to 0, 6 plus 3 will get 9 and 3 plus 0 will get 3. Okay, so here we got these two zeros and we need to get one more this. Think here this is it, this is a 3 into 4 matrix, don't forget that. So here we have got this, here we need to get more here 0, right? So for that we need to do R2 implies, okay, R2 implies what we can do here, 3 into, here row 2 plus 3R1, okay, row 2 plus 3R1, therefore we'll get matrix. Here row 1 is as it is, okay, so minus 1 4 6 3 is as it is, and here R2 plus 3R1, so 3 minus 3 is 0, 2 minus 12 means minus 10, 1 minus, oh shit, wait a minute, here just we have done a small mistake. Here R2 plus 3R1, no, so 2 plus 3 is 12, right, 12 plus 2 will get 14, here 1 plus 6 3 is 18, will get 19, here 0 plus 3 3 is 9, so 9, and this matrix is as it is. So here you know that now we have got these elements 0, right? Therefore for this the rank of a matrix will be 3. Okay, or else in rectangular matrix also we can, in rectangular matrix you can do this method by finding the determinant in making a 3 into 3 matrix and 3 into 3 submatrix, and you can do. So this is the way how we need to find. If you have any doubts, please write them in the comment, and every doubt will be clear by you and by me. So please, if you like this video, comment and share and subscribe this video. Thank you.